Okay, let's go through some drawing exercises. We're on page 7 of the organic chemistry packet. So methylpropane, I see prop, so I'm going to draw 3 carbons in a row. I see ane, which tells me that it's just an alkane, all single bonds. Methyl tells me there's 1 carbon as a branch, and branches have to go off of middle carbons, not end carbons. Therefore, this is the main structure of this molecule. Now, on the IB exam, you've got to draw in H's, and not just as lines like this, but actually take the time to draw in every single H. Now, for the rest of this video, I'm going to skip that part just for the sake of everybody's time, but that is what makes it a full correct structure. This thing on the left does not get you any marks on the IB exam. Dimethylpropane. So prop is 3. Once again, ane, all single bonds. Dimethyl means 2 times 1 carbon. And so the only place I can put branches is off middle carbons. Therefore, that's dimethylpropane. Methylbutane. Start with but, which is 4. All single bonds for ane. And then methyl, there's 1 carbon. Now, you might think you have 2 different options. You can put that one there, or you can put it there. So on the second or the third, but actually these molecules are the same, because if I take this molecule and I rotate it around 180 degrees, it becomes this molecule. They're really the same. And if you try to number them, you'll get the same name. What I mean by that is when you number, you always want to give the lowest number. So this is the first carbon, and that's the second carbon, and then 3, and then 4. So this is, the methyl group is on the 2. Well, for this one below, I wouldn't number from this side. That would make it 3-methyl. I would number from the right-hand side, 1, 2. So I've got a butane molecule here. It has a methyl off to the side, and either way, there's a way to consider that carbon is off of the second carbon. That's why there's really only one thing to draw, and that's why they haven't given you a number. Because sometimes, you might write 2-methylbutane, and that's fine, 2 in general. But sometimes the IB considers this number sort of redundant. It's not really needed since there's only one place to put a methyl on a butane, and so they will take that number away. Okay, moving on. Let's go back to purple. Wrong purple. There we go. Okay, butane 4,2,3-dimethyl. So now there's 1 on the 2 and 1 on the 3. 2,2-dimethyl. There's both of them are on the 2. So even though there's 2 methyls, so there's 2 times 1 carbon, and where are they? They're both on the 2. So even though it might seem like overkill to list the 2 twice, if you tell me there are 2 methyl groups, I need a number for each. If numbers are needed, if there's more than one option. 1, 2, 3, trichloropropane. So start with the prop, 1, 2, 3 carbons long. And then there's 3 chlorines, and where are they? They're on the 1, the 2, and the 3. Propan-2-ol, 1, 2, 3 for prop. Now this is the first one with a different ending. The ol tells you, like it tells you up here in this table, the ol tells you that this molecule is an alcohol. And that means it has an OH as its functional group. That's the part of the molecule that gives it special character, special property, that makes it act like an alcohol. So where is that thing? Well, the reason why there's a 2 right in front of the ol is because it's telling you where that ol part is. So off of carbon, we draw OH. Now, really, that OH, if we were drawing out all the bonds, there's a bond to O, and then there's another bond to H, and this O would have these lone pairs. But in organic, we kind of condense things down, otherwise they get a little bit too messy. So this is the way that we'll draw it in organic chemistry. So that's propan-2-ol. This is methylpropan-2-ol. So it's still propan-2-ol, but now there's a methyl. Where do methyls go? They can't go on the ends, so they branch off of the central carbon. Okay, pentanoic acid. So 5 for pent, and then anoic acid. So let's look up here. I've got anoic acid means it has this group, a carboxylic acid group or a carboxyl group, COOH. So C double bonded to O and then single bonded to OH. And there's no number given, and that's because the nature of that functional group is that it's always at the end of a chain. You can see this carbon has 3 bonds coming out of it. That means it only has this one other bond to continue on to the rest of the chain. And that's why I don't need to give a number, because I know it's going to be at the end. I know it's going to be the number 1 carbon. So I can draw it here, or I can draw it here. I tend to draw it on the right-hand side just because that's kind of how I'm used to seeing it in books and things. So that's pentanoic acid. The carbon that's in the acid group, this one, it counts as one of the 5 carbons in the pent part of it. Okay. And then last, hexanoic and 3 bromo. So I've got my hex part first. I draw 6 in a row. I'm going to make the anoic acid part here on the, and I'm going to put it at the end. And the trick here is that makes this carbon the number 1 carbon. Because we always try to give the lowest numbers, and we give the lowest numbers to the most important things. So the carboxylic acid, the functional group part, is the most important thing. And if this is the number 1, then this carbon is the number 3. Now, a lot of people, when you first do this, you'd probably put the bromine here, because that seems like 1, 2, 3. That's got to be the 3rd carbon, because it's the 3rd from the end. But that's mostly because we're used to numbering things left to right in English. So just try to get out of that way of thinking there. You can number things left to right, but also from right to left, and you should pick the one that gives us the lower numbers when you have a choice, and especially the lower number for functional groups, for things that are important. Okay, now we're going to quickly go through some name solutions. So I see a chain of 4, so that's bute. I see this OH group, so that means anol. And I want to know where that is. The lowest number I can give that OH is a number 2. So it's butane 2-ol. I don't see anything else in the molecule, so I'm done. I see 3 carbons, that's prop. I see a chlorine, which is kind of like a functional group, but the halogens don't actually change the ending. They get added in front of the name as a prefix. So this is just going to be called propane, because it's all single bonds. But on the front, I'm going to stick a chloro. And where is it? It's on the number 1. So because that chlorine could be on any carbon in this molecule, I have to tell you where it is. That's a number 1. Same thing for the OH. The OH could have been on the first carbon or the second, therefore a number is needed. Okay, 3 carbons here, that's prop. This group here is a carboxylic acid group, so that makes the ending anoic acid, so propanoic acid. There's no number needed because the carboxylic acids are always at the end, and there's nothing else on the molecule, so that's just propanoic acid. Okay, this one, I see a chain of 3 that includes this iodine thing. It's kind of subtle that that's there. And this one has a single carbon. So 3 carbons in the longest chain is prop. Everything, if we kind of sketch it out, this is a more condensed formula, seems to be single bonded. And there's an iodine over here. Okay, so that means it's propane. Now I have to tell you about both this iodine and I have to tell you about this methyl group. So I've got iodo, is how we name iodine, and I've got methyl. So I can see when I look at the name that there's an iodine on it, there's a 1 carbon branch, and then there's a 3 carbon chain, and that adds up to 4 carbons in the molecule. Now the iodine I need to number, because the iodine can be anywhere on this chain, and so I'd say 1 is the lowest number I can give it. The methyl doesn't actually need to be numbered because, again, methyls always come off of middle carbons, not end carbons. So I could put a 2-methyl there, but I don't really need it. Okay, I've got 2 carbons, F. I've only got halogens, so it's ethane. And I've got 1, 2, 3, 4 of them. So when you have 4 of something, it's not di or tri, but tetra. So this is tetrachloroethane. And believe it or not, there's actually more than 1 tetrachloroethane. You could put the chlorines, you could have 3 of them on 1 carbon and 1 on the other. And if there's more than 1 option, that means you've got to number things. So where are these chlorines? Well, 2 of them are on the first carbon and 2 of them are on the second carbon. It doesn't matter if I think left to right or right to left. So that means it's 1, 1, 2, 2 tetrachloroethane. It's a mouthful, but it's actually really informative and helpful if I'm trying to draw this thing. Okay, this one I see 2 carbons, it's F. I see 2 OH groups, so it's definitely going to be like a nol. It's definitely an alcohol, but it's actually something called a diol, which is not very important or common, but actually I've seen this example on the IB exam, which always annoyed me, but it's okay, we can handle it. So the only weird thing is that instead of calling it ethane diol, they call it ethane. And then where are the 2 alls? They are on the first carbon and the second carbon. So let's sneak those numbers in there. Oops, and I did it wrong. Let's get rid of that all bit and write diol. Because if I see 2 numbers, I should see a di there to tell me that there's 2 of it. So again, let's break it down. I've got a 2 carbon molecule, ethane, all single bonds. I've got 2 OH groups, diol, and where are they? They are on the 1 and the 2. So that's the name. Okay, almost there. We've got 3 prop. We've got anoic acid, which doesn't need a number because it's always on the 1. If this is the 1, then that's the 2, and that's methyl. Sticking off of that, there's 1 carbon off of that. No number needed on that methyl. Okay, 8 is a sneaky one. The longest chain is not necessarily left to right. Okay, so the longest chain is actually this. You get good at spotting it the more you practice, but the longest chain is actually pent. Will the IB do that? Of course they'll try to do that to you, potentially. You've got to look for the longest chain. It's not always just whatever is written left to right. So pent is the longest chain. I see this group here, so that becomes pent anoic acid. No number needed on oic acids, on carboxylic acids. There's still one thing I haven't named, though. That's this methyl group. And I got to think where it is. Well, if I number, this has to get a 1. That's a 2. And so this is the 3rd carbon. So we're going to call this 3-methyl pentanoic acid. There are a lot of middle carbons in a pent molecule. There's 3 in the middle. So that's why the methyl could have many different positions. And so that's why we've got to stick with using a number. Okay, long chain is 5. Pent, going pentane, and then there's 1, 2, 3 different methyl groups. So it's trimethyl. That's not a propyl group. A propyl group would be like 3 carbons in a row, in a chain, sticking off to the side. These are 3 1-carbon branches, so we say trimethyl. Okay, where are they? Because there's different places I could put these 3 methyl groups, I have to tell you where they are with numbers. And so either this is the 2 carbon, so I'd get 2, 2, 3, or if I numbered from right to left, I'd get 3, 4, 4. I think lower numbers are better. 2, 2, 3, dash, trimethyl pentane. Okay, last one here. Once again, the longest chain is hidden. Okay, so we've got that. That's actually pentane. And then we've got a methyl group and a methyl group. Where are they? 2, 3 dimethyl is the best way to name those. So I'm going to end the solution video here. There are some other ones on this page for further practice, and in fact, practice with isomers. So I'm going to post the answers to those, and you can check your work on that page as well.